All right, so what we're going to be looking at here in this video is an introduction to triangles. We've got a few different essential questions here that we're going to try to answer. We've got how is a triangle classified, and what are the basic properties of triangles. Those are going to be the things that we're going to try to answer by the end of our video here. And we're going to start off with classifying the triangles. Now, there's two different ways to classify a triangle. The first way that we're going to look at is to classify a triangle by its sides. So there's three different classifications for triangles when you're looking at the three sides of the triangle. First of which is the scalene triangle. A scalene triangle has 0 congruent sides. So, for instance, you might see a triangle like this, where maybe this is 3, this is 4, and this is 5. Right? All three sides are different lengths, so it has 0 congruent sides, so it's scalene. Next up is the isosceles. An isosceles triangle has 2 congruent sides. So an isosceles triangle might look something like this, where you've got maybe this side is 5, this side is 5, and this side is 4. So these two sides would be congruent, so they can get the little tick marks. And so it's got those 2 congruent sides, so it's isosceles. And lastly, we have the equilateral triangle. An equilateral triangle has 3 congruent sides. So all 3 sides are going to be the same. So maybe all 3 sides are 10. So all 3 sides get little tick marks. So that's going to be our equilateral triangle. Now there's another way of classifying triangles as well, because triangles don't just have 3 sides, they also have 3 angles. So by looking at its angles, we can also classify the triangle. So the first way of classifying a triangle by its angles is an acute triangle. An acute triangle has 3 acute angles. So that means that all 3 of its angles are going to be less than 90. So maybe we've got something like 70 here, 60 here, and 50 here. All 3 of those angles are less than 90, so it would be an acute triangle. Next, we've got the obtuse triangle. An obtuse triangle is a triangle that has 1 obtuse angle. Now, obtuse, if you remember, means that it is greater than 90. So maybe it's going to look like this. Maybe we've got this big 100-degree angle up there, and this one is 50, and this one is 30. For reasons that we'll look at later on in this video, you can only have 1 obtuse angle. So an obtuse triangle doesn't need to have 3 obtuse angles, because that would actually be impossible. And like I said, we'll see why exactly later on here. And then we also have the right triangle. Now, a right triangle is going to have 1 right angle. So that might look something like this, where normally you'll see that red box down there, that'll indicate that it's a right angle. That's 90 degrees, if you don't remember that. And there we go. We got these 2 other acute angles. Once again, we'll see exactly why later on, but you can only have 1 right angle. Now, you can classify these triangles these 2 different ways, and oftentimes we're going to classify them using both, because every single triangle that we're going to see is actually scalene, isosceles, or equilateral, and acute, obtuse, or right. So we're going to need both of those here at the bottom. So this says classify the triangle by its sides and angles. So let's look at this one on the left first. Now, looking at its sides, we can see that we've got a 20, a 48, and a 52. So all 3 of those sides are different. So this is going to be scalene. And then I also see that it's got that right angle. So this is a scalene right triangle. Looking at our next one, I see that all 3 of those angles, all 3 of the sides are congruent. All 3 of them are 5. So we've got all 3 being 5. So that means it's going to be equilateral. And all three angles are less than 90, right? They're all 60 degrees. So that means it's acute. So that would be an equilateral acute triangle. And then lastly, looking over at the one on the right, I see that I've got two sides that are 13. So that means that it's got two congruent sides, so it's isosceles. And it's also got that 128 degree angle, which is an obtuse angle. So this would be isosceles and obtuse. Okay, so we know the terms for classifying. Now let's get into the properties of triangles. We know how to classify them. Let's take a look at what's going on the inside of these things. So if you open those notes up, we'll get on to the inside here. Okay, so what's it say up at the top? It said, after Euclid's work with the building blocks of geometry and parallel lines, he moved on to polygons, starting with triangles. He began with the triangle sum theorem. So you might remember Euclid, the father of geometry. He is, way back in the day, he proved all these facts that we're going through. And so when he got on to polygons, the smallest polygon is the triangle. So he obviously started there, and he started investigating what's going on with them. And he came up with this thing called the triangle sum theorem. The triangle sum theorem says that the sum of the measures of the interior angles of a triangle is equal to 180 degrees. So what does that look like? Well, if we've got a triangle, triangles obviously have three angles, right? So let's number those three angles. And the triangle sum theorem says that if you take all three of those angles and add them together, it has to be equal to 180. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be equal to 180. That is what the triangle sum theorem says. And this is going to be incredibly instrumental to our success throughout geometry. Got to know that. And what we're going to do here below is we're actually going to try to do the proof that Euclid did to prove why those three angles always have to add up to be 180 degrees. All right. So example 2 says, prove that the triangle sum theorem is true. And we've got a given here. This given says that ZA is parallel to XY. Okay, so let's start off with that. And we'll take a look at what that even is referring to here. Because this diagram looks kind of funky, but this is the way that Euclid set it up. So we got ZA is parallel to XY. Given. Okay. Now, ZA and XY, that's this line and this line. So it looks like in order to make this thing kind of happen, Euclid started off by drawing a line that was parallel to one of the sides of the triangle through the other vertex. So he took that side XY and he constructed a line through Z such that it was parallel to XY. And that kind of makes sense because he just got done doing all those work with parallel lines, right? So he knows a bunch of things about parallel lines. Okay. So what do we want to do here? Let's start off, and this is going to seem kind of goofy, I won't lie. But let's start off by saying that the measure of angle 1 plus the measure of angle 5 is equal to the measure of angle XZA. Now, if you look at what I just did, that's this plus this equals this, okay? And And I know that that probably seems very strange for a first move here. But that is the angle addition postulate. Angle addition postulate says that you can add the two small pieces to equal the big one. Now the reason that I'm doing that is because I see that that big purple angle that I just did, ECA, that is a linear pair with angle 4, right? Angle 4 plus the purple angle has to equal 180. So the measure of angle 4 plus the measure of angle XZA is equal to 180 because that's a linear pair. Now, once again, this is probably seeming kind of strange, but the reason we're doing this is because now we actually have something with 180. If you looked at what we were trying to prove, of course, we're trying to prove that 1 plus 2 plus 3 equals 180, the three interior angles. We're trying to prove that the three interior angles of a triangle equal 180. And now we finally have something with 180. All right, let me keep my color coding going here so that we can kind of follow along. Right now I've got yellow plus purple equals 180 because that's a linear pair. Now we just established that purple is made up of green and blue. So I'm going to do some substitution here. Now I'm going to say 4 plus 1 plus 5 equals 180 by the substitution property. And now we've got yellow plus green plus blue equals 180. And some of you guys probably saw that from the very beginning. We had to kind of go through that angle addition thing because the linear pair postulate, it's a pair of angles, right? It can only be two. You can't say that 3 angles add up to be 180 using the linear pair postulate. Okay. So now we're close. We're close. If we think back to those parallel lines, because we have those parallel lines and we haven't done anything with them. Hopefully what you guys have seen is that 4 and 2 are actually alternate interior angles, right? And the same thing goes with 5 and 3. 4 and 2 are alternate interior angles, and 5 and 3 are alternate interior angles. And what do we know about alternate interior angles if the lines are parallel? Well, we should know that they're congruent. So here's what we're going to do. To save some space, we are going to do a little combo here. I'm going to say that angle 2 is congruent to angle 4, and angle 3 is congruent to angle 5, because of the alternate interior angle theorem. So we've got those two angles being congruent. Now, we're super close because some of you guys can probably see that all we have to do is replace 4 with 2 and 5 with 3, and then we have what we were trying to prove. But the problem is that what we just said was that these angles are congruent and not that their measures were equal. So we got to take one more step here to convert those congruencies into equalities using the definition of congruence. And now we can finally do a little substitution here. So now I can finally say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 by substitution property. And if you didn't catch exactly what I did there, I took 2, plugged it in for 4 there, and I took 3, and I plugged it in for 5. And then we just did a little bit of rearranging there, and then we got what we were trying to prove. So that is the reason why all triangles have to add up to be 180 when we're looking at those interior angles. Okay, so let's dive in a little bit further here and take a look at some examples here. This one just says solve for x and classify the triangle. Easy enough. We've got those 3 interior angles. Let's add them all up. If I add up all 3 interior angles and know that they got to add up to be 180. Combine some like terms here, x and 2x, that's 4x plus 20 is equal to 180. If I subtract the 20, I get 4x is equal to 160. Divide, and x is 40. Now if x is 40 and I plug that back in, that angle's 40, that angle's 40. 2 times 40 is 80, plus 20 is 100. And so if I've got 2 angles that are 40 and 1 angle that is 100, those 2 angles there are 40, the bottom one's 100. So I've got 1 obtuse angle, so this is going to be an obtuse triangle. And we don't know anything about the sides right now. So for right now, we can't say anything about classifying it by its sides. Later on, you'll learn how to tell just by looking at the angles. But for now, that's an obtuse triangle. Let's move on to example 4 here. Let's take those 3 angles again. Add them on up. Set them equal to 180. I've got a 2x, a 4x, and a 10x. 2x plus 4x is 6x. Plus 10x. I don't know why I didn't add all those all at once. Let's do that. 2 and 4 is 6, plus 10 is 16x. Minus 4 and a minus 8 is a minus 12. It's equal to 180. If I add the 12 over, I get 192. And 192 divided by 16 should be 12. Now if I plug that 12 back in, let's see what happens here. The 10x, 10 times 12 is 120. 2 times 12 is 24, minus 4 is 20. And then 4 times 12 is 48, minus 8 is 40. So I've got a 20, a 40, and a 120. That is 1 obtuse angle, so we can say that this is definitely an obtuse triangle for right now. Once again, we don't know anything about the sides at this moment, so we can't say anything about the sides. All right, so let's go up to the top here. And this says, next, after looking at the interior angles, Euclid moved on to angles outside of the triangles. He discovered the exterior angle theorem. So what does the exterior angle theorem say? The exterior angle theorem says that the sum of the measures of the 2 remote interior angles of a triangle is equal to the measure of the exterior angle. Okay, so without a picture, that might be a little confusing. Here's what that's going to look like. If you've got a triangle, you've obviously got the 3 interior angles. But if you extend one of the sides out, you're going to form what's called an exterior angle. And the exterior angle theorem says that the sum of the 2 interior angles that are not adjacent with the exterior angle. So that is 1 and 2, because 3 is the one that's adjacent to the exterior angle. the sum of those two has to be equal to the exterior one, which in this case is 4. So the exterior angle theorem is going to say 1 plus 2 equals 4. Which sounds funny because 1 plus 2 doesn't equal 4. But in terms of the angles, yeah, it does. Okay, so now what we're going to try to do is prove why that is true. It says prove that the exterior angle theorem is true. And what we have right now is just that exterior angle. So the given just says that we've got an exterior angle that's angle 4. Okay, now you should remember, of course, now that we've proven that it's true, that the triangle sum theorem says that those 3 interior angles, 1, 2, and 3, have to equal 180. That is the triangle sum theorem. We just proved why that works. And then, of course, we should also see that 3 and 4 are a linear pair. So 3 plus 4 has to equal 180 because of the linear pair postulate. Now notice that we've got 2 equations there from the 2 previous steps that are both equal to 180. So if I do a little bit of transitive property, I get the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be equal to the measure of angle 3 plus the measure of angle 4. Since they're both equal to the same thing, the transitive property lets us set them equal to each other. And then, check this out. Bam, bam. There's the measure of angle 3 on both sides. And if I do the subtraction property, I get the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4 because I subtracted 3's from both sides. And voila. We arrived at our conclusion. So that's why that theorem's going to work every single time. Now let's try it out. If we look at these bottom ones here, we shall set up some exterior angle theorems. Example 6 over here, we got those 2 interior angles, 50 and 60. We know that if we add those together, it's got to be equal to 11x plus 3. 50 and 60 equal 110. If I subtract the 3, I get 107. It's equal to 11x. Well, that's not going to be a nice number, is it? 107 divided by 11 is, we'll just round it to 9.7. Okay. Now we've got x being 9.7, rounding to the nearest tenth. And by doing the triangle sum theorem, if I do 50 plus 60, of course I get 110. 180 minus 110 is 70. So that angle's got to be 70. Which means that all 3 of those angles are less than 90. So this does mean that that triangle is an acute triangle, because it does say to classify it as well. Okay, then example 7 over here. If we take the sum of the 2 interior angles, that's 90 and 7x plus 2. We add those together, it's got to be equal to the exterior, which is 29x plus 4. 90 and 2 give me 92 equals 29x plus 4. Subtracting the 7x gives me 22x plus 4. Subtracting the 4 gives me 88. And then we divide and we get that x is 4. So if x is 4, then the 7x plus 2 is 28 plus 2, that's 30. So 90 plus 30 is 120. 180 minus 120 is 60. So that tells me that this angle is 60. So I've got a 90, a 30, and a 60. I guess I knew from the very beginning that that was a right triangle, but still good to find that third angle. Okay, we did some triangle sum theorem, some exterior angle theorem, and we proved why both of those work. For the your turn side, you've got some interior angles, some exterior angles. You're going to be solving for x and then classifying the triangles. So why don't you pause the video here, try those out, and then come back when you are ready to check. All right, hopefully you paused it and you had some good luck with those. Let's see how this goes. So for number 1, 40 plus 11x plus 1 is equal to 180. That should be 11x plus 81 is equal to 180. Subtracting gives me 11x is equal to 99, so x was 9. Plugging it back in, 99 plus 1 is 100. So this does become an obtuse triangle. Once again, we can't really classify by sides yet because we don't know anything about the sides. Number 2 says solve for x and classify the triangle. Okay, so this is an exterior angle, so this should be x plus 60 is equal to 3x minus 60. If I subtract the x, I got 2x over here. Adding the 60 gives me 120. And then dividing gives me 60. So x is 60. Plugging the 60 back in, I get 60 there. The third angle in the triangle, if I do 60 plus 60, I get 120. 180 minus 120 is 60. So all three angles are 60, which means that this is acute. For this one, let's add up all that stuff. 55 plus 2x plus 70 minus 4x is equal to 180. 55 and 55 is 110. Plus 70 is 180. 2x minus 4x is minus 2x. If I subtract the 180, I get negative 2x is equal to 0. So dividing by negative 2 tells me that x is actually 0 on this one. That's kind of strange. And plugging the 0 back in means that this angle's just 55 and this angle's just 70, which does add up to 180, so that's cool. And all three of those are less than 180, so this is an acute triangle. Over here, let's solve for x. We've got a 90, don't forget about that 90. 8x minus 2 and a 2x plus 2, all equal to 180. 8x and 2x is 10x. 90 minus 2 plus 2 is just 90. Subtract the 90, we get 10x is equal to 90, so x is 9. I'm plugging that back in. 2 times 9 is 18, plus 2 is 20. 8 times 9 is 72, minus 2 is 70. 70 and 20 and 90 do equal 180, so that's good. And we have a right angle, so this is a right triangle. Down here, we got a 90 and a 10x plus 3 must be equal to the exterior angle. That's 10x plus 93 is equal to 7x plus 102. Subtracting is 3x plus 93 is equal to 102. Minus the 93 gives me 9. So x is 3. And plugging that back in gives me 10 times 3 is 30, plus 3 is 33. 90 plus 33 is 123. 180 minus 123 is 57. But I guess we knew we had that right angle, so it had to be a right triangle the whole time. Last one is another exterior angle. We got a 2x and a 2x minus 1. Must be equal to a 2x plus 65. That's a 4x minus 1 is equal to a 2x plus 65. Subtracting the 2x gives me 2x minus 1 is equal to 65. That's 2x is equal to 66, so x is 33. Plugging that back in, this angle is 66, this angle is 65. 66 plus 65 is 131. 180 minus 131 is 49. So this angle is 49, which means that all three of them are less than 90, so this is an acute triangle. All right, hopefully you guys did pretty well, and that's going to wrap it up for this video.